Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Oh, good evening, everybody. I'm in my third tier of hell at the moment. I'm managing my boss's tow business, and I got to tell you, the telephone has not stopped ringing for 2 days. And if I had hair, I would have ripped it all forth from my scalp and thrown it in the trash at this point. It has been a wild last week and a half. But that's got nothing to do with what we're doing here. We have the Titan, Ten-Tec Titan here, and yes, this is the one with the pair of 800s in it. Specifically the 3CX 800s. Whoa, whoa. Whoa, exposure. Calm down. 3CX 800s. Our friend John, he sent this to me over a year ago at this point, and he says, man, there's something wrong with the power supply, there's something wrong with the amp. Come to find out, he's had this thing since like 19 whatever, and he's had it since it was new. And he's talked on this thing a minimum of 45 to 3 hours every day ever since. Well, we've already done one YouTube video on this amp. This is video number 2. So it's a clean one owner. Got driven hard every day, but only on Sundays to the church. And what we're here to do today is to repair it, finally. This is the one where I did a simple anode to grid ring high pot test with a neon sine transformer. And these were breaking down and shorting over at 800 volts. These tubes are done. They are at the end of their life. They have got nothing more to give this world. They are done. So I came out and I did a YouTube video hoping I could find somebody that had some of these, because they're very, 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 very rare to find. Well, you found a kind guy in Arizona that the dude, yeah, this is the one that was arcing over at like 800 volts. These tubes are junk. They're just done. They're shorted out on the inside, they're shorted out on the outside. They're shorted out. You found a nice guy in Arizona that, well, had a set of these. So this isn't a simple tube swap, though, unfortunately. We've had some catastrophic failures and things. On this side of the amplifier, a little bit of dust. I've got to clean the fan. The fan looks like it was a intake freaking louver for a dryer. Look at this. It's just a wee bit dusty. It's just a wee bit dusty in there. It's okay, I got this technology called a tornado. Look at that, isn't that pretty? We'll go in there and we'll blow all that out from the other side. All this shit will come flying out of there like a Mach 4. Over here, this glitch resistor has gone on to see Jesus. It's given up its ghost and said, no more! High voltage comes in, obviously goes through this little resistor, comes back out, runs over, goes through the plate choke, comes out the plate choke, and goes over to our parasitic suppressors and then onto our anodes. Well, there's a resistor that's here, and then there's another resistor that's in the power supply. It looks just as effed off as this. So, we went to digging. I had a very nice gentleman from the Southern Persuasion of the United States send me in the mail. He had a giant filing cabinet full of resistors. Wire wound resistors. Now these are Ormite. These are 10 ohm These are 25 watt. These are glitches. And the idea is that if the tube shorts out or anything happens with the PA deck and we have high voltage that it manages to find its way to ground, these are the sacrificial lambs. Right? We're going to throw them up on the altar of high voltage and we're going to kill them deader than Jesus. No, we're not talking about dragging them up on the cross, and we're talking about making them disappear into a cloud of smoke. Atomization, man. So these did their job. They failed hard for a reason. The tubes breaking down. The one that's inside the power supply, which we'll show you here in a minute, I believe this is the one that was in the power supply, to be honest with you. It's an Ormite, 10 ohm, 25 watt. Well, because of other people's gifts into our world, I ended up selling this guy a Henry 2K, like a 2KD4. Came a screaming deal on it. And in turn, we have this. This is a 10 ohm, 25 watt resistor, but this is what they call an adjustable resistor. There's a third armature that sits over this resistor, and you can move it back and forth, and it moves down the nichromium wire and decreases the resistance. So from pin to pin, it's 10 ohms. Or you can move the slider up and down the resistor, and you can take it down to like 1 ohm, 2 ohm, 3 ohm, 4 ohm, 5 ohm, 6 ohm, so on and so on. But this is the right watts, and this is the right amount of resistance, so therefore it'll have the appropriate actions on the circuit. So I'll dig this burn up pile of dog poop out of here, and we'll replace it with this, which will work beautifully. It'll sit right in here. Then I got to take the high volt board apart in the power supply, replace, once again, this resistor is a wide open. I think I showed this in the other video. This one blew completely open, where this one was a slow cook. It sat here and just cooked on, and cooked on. As you can see, pretty clean and new. Fricasseed, burnt down dog poop. It's okay. I do quietly question myself how I didn't smell this, but in the same breath, they put this resistor directly in front of the intake for the PA deck. This is a blower. It pulls air from the inside of the cabinet, from all over, pressurizes the bottom side of the tube socket, air comes up and goes out through the top of the tube. So this smoke from that resistor got intermixed with gallons and gallons and gallons of other air. So it was a slow burn. Doesn't surprise me he missed it. But here we go. So we'll pull this out and we'll get this deck ready to go again. But what we're going to do after that is this guy in Arizona was kind enough to send him, supposedly, brand new, unknown manufacturer. We'll find out when we get inside the box. But these were incredibly expensive. Incredibly expensive. We'll go ahead and we'll put these up in here, and then what we'll do is we'll bring the high voltage on and we'll power the whole deck up, and we're going to sit here and we're going to watch it. We're going to bring it on real slow. We're not going to bring the high voltage onto the tubes. We're going to let these cook, because we don't know how old these really are. We don't know, and we don't know if they've actually maintained their vacuum or not, which you can have what they call a micro crack take place from the ground ring to the insulator ring. This is nothing but high temp glass. This is a form of porcelain or jade, but it's glass. Nonetheless, it's glass. This is your insulator from your anode, and the reason that you're able to get such a high kV rating, internally, the internal resistance for the high voltage is the vacuum. These tubes have lost their shmoo. That, and there's physically something broken down on the inside. You got part of the screen or the grid. Grab one of these 3000s I got sitting here. Yeah, here. This is a perfect example. This is the inside of a 3CX3000A7. And when you go and you put high voltage on this thing, it says there's no problem. I mean, when you go and you put a multimeter on this, it says there's no problem. But when you go to put high voltage on this tube, there's an inner screen and an outer screen, and then this center rod's called a bobbin. Okay, the bobbin rod in the middle, which attaches to the top of the bobbin cap, which attaches your grid ring, Okay, and then inside of this is your filament structure. So this is what is the gatekeeper to the universe, this outer screen. What I mean by the gatekeeper is it keeps the electrons in and controls the tube. Well, let me set this down to where it's static. And let's zoom in here and let's take a quick focus. We're going to go to El Manuel. Okay. You can't see it, but there's a hole right in front of you. You can clearly see there's an inner structure and an outer structure of this thing. Let me rotate this around. You see the hole? You see the hole? Now look at how the little tiny pieces of nichromium, tungsten, blah, 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 schmick, it's on the inside of this tube. See how the wires are broke down? You see that vertical string? For every one of these fingers here at the bottom, there's an attachment point up here on the top of the bobbin head. So that's your internal filament structure. Your little tiny wires. A little tiny wire comes off a finger here. Off each one of these little fingers, there should be a vertical riser. Well, this tube is way at the end of its life. Way, way, way at the end of its life. And what has happened is we've had an internal hard short. Okay? If we take a ruler and we line up this fingy to the opening of the screen, you'll see that the screen is shorted to the filament at some point or another. It's not only done it there, but every one of these fingers is effed off because they've all broken and fallen against the screen, which is causing a high voltage short internally on the tube. Look at this. This one's melted into place. You see it now? Kind of cool, I know. But that's how it works. Look at this. There's a piece of it laying down across the screen, trapped between the filament and this internal cage. So, if you wanted one that looked completely intact, but has lost all of its magic shmoo, I would show you this one. This is the inside of a Schmidt-Lana. This is what they call a mesh. Okay. This is an iMac. This is an American tube. This is a rebuildable unit because the people in the United States understand how to rebuild this. These are exactly the same tube. They have the same height, the exact same amount of dissipation. Up here is a magnetically driven getter. The American tubes don't do this. That's what these little pieces of sacrificial metal are here on the top. You can heat these with a magnetic induction heater, and it'll pull even a harder vacuum on top of the mechanical vacuum that you apply to the tube to get the seal. They've got them down here on the collar. But this is a non-rebuildable tube. This is what they call mesh. And the reason they call it a mesh is because it's spiral wrapped. The outside is a vertical screen and then held together with a spiral wrap backer, where this is a vertical outside screen and a horizontal wrap. That's what differentiates the two. They achieve the exact same job. They're just slightly different. This one here has lost its vacuum at some point in its life. And it was a slow leak because this thing was obviously in operation and the filament was lit. Look at how dark the inside of this is. This is when oxygen is creeped inside of the tube. Slow leak, filament lit. The oxygen started to react with the metal on the inside of the tube here. The tungsten, can't remember the exact name right at this second. And it started to oxide and disintegrate. It created smoke. This is a filament short, this is a vacuum leak. But I keep these two around so people can have a visual idea of what we're looking at on the inside of the tube. This same structure is inside of this guy, just on a smaller level. Okay, a little bit smaller level, smaller design, smaller. 3CX 800A7. This tube has done something like what has gone on inside of this tube. Okay, so the inside of this tube looks closely to this. That, and this is 20-year-old everyday use. I bet you if we were to cut this tube open, it would look a lot more like this versus that. But this is what demonstrates our closest characteristics on the outside of the tube that we can make a reference to. So, On that note, we're going to fix this. We're going to fix the other resistor. We're going to check all the diodes. We're going to check our capacitors. We're going to turn this thing on slow. We're going to bring on the power supply. We're going to make sure that we don't have any ripple or any leak. And then, after we bleed all the power out of the entire equation, get all the high voltage, make it all go away. So that means transformer on plate needs to go inside of permanent holding device, metal enclosed groundable cabinet that keeps you from getting electrocuted and dying. I cringe when I see these guys on Facebook. Look at my power supply. It's inside of a plywood box. It's safe. No, it's not. No. No, it's not. The biggest pet peeve I have about this entire thing is that this is a two-piece unit. Okay. We need to have power supply in a meter in two places. One here and one here. The reason why is because we connect the two with connections of death. All right. This connection is cute. It's thread on, at least not push button. This connection will kill you. You put your hands on that when the high voltage is in play, you die. Most likely not completely dead, but it's going to hurt a whole lot, and you're most likely going to hurt for a while. If this has some kind of crack in it, a micro crack or something, and it's just looking for a way to get back to the ground, and it decides to use you and cross your heart and find that path, you die. The reason I say that we have to have 2 meters is you need to see what you got for voltage at the head unit, and then the power supply itself, to make sure everything is discharged after everything is shut off, you should have a separate meter inside the power supply. That way you know it's perfectly safe, because you don't know if this connection is bad coming off the back of the amplifier. This meter is going to read 0, but there still might be plenty of death dragging in the tube. Right? Like playing with heroin. Take one little bump one time and you're stuck on it forever. Well, you take one little bump from this forever and you're dead forever. It's like heroin. People that do heroin, they're dead. They just don't even know they're dead yet. It's sad, but it's true. It's really sad, actually. And it's really true. Or if you had a secondary meter, not that most people would have enough sense to look at the secondary meter and go, oh, look, there's still high voltage. I should not put my hand on the wire and then touch the cabinet. Because you and I, we're filthy, lazy Americans, just like everybody else. And we're going to rest our hand here and grab a hole over here and go to twisting. You're creating a bridge from the high voltage up through your arm, across your man chest, and out to your other arm. And you die. And it's from cardiac arrest. So basically you suffocate. Not only will this kill you, it'll hurt the entire time while dying. 3,000 volts is relatively low. Don't get me wrong. I mean, I love working on these little tiny tubers at this low voltage. It's relatively safe-ish. Compared to the world that I normally live in, which is 10 and 15,000 volts at like 7 and 8 amps. This is 3,000 volts at about a half an amp to an amp at the most. Huge electrical potential differences. But still, I digress. I personally feel that this should have a high voltage meter in here for safety, period. But Ten-Tec, the lords of Ten-Tec, they decided otherwise. It's just like the Palomar 900A. I think it should have a high volt meter on it too. I think it should have a high volt meter on both ends of the hose. This end and that end. Points proven. Okay, so first step, let's fix resistors. So this, I know there's nothing wrong in the head unit other than this resistor. So we're going to change this out and we're going to quickly shuffle this aside. I'm going to get out the tornado detailing tool. We'll get this sucker all cleaned up. And then we'll set this aside. Then we're going to come over here, and when I come back, we're going to be fiddly farting around inside that thing for a hot minute. Okay, so let's get this. Let's get down to business. So this has seen better days. Like legit. So let's put that back on auto. This technically tests-ish. It's like 8.5 ohms. It's not open, but I went ahead and replaced it. It's in there, and it's it's all hooked up now. I checked all the diodes. Let me rotate this up. I got a transformer just held in there with one bolt. It's all connected. And down in here is where that new, right there is where that new glitch resistor went. I'm going to set this back down. I have some personal reservations about this power cable. It's got multiple spots with electrical tape on it, and what's going on is the jacket is just, well, it's just disintegrating. So before I power this up, tomorrow I'll try to get over to Ace or something, and I'm going to get you some new wire for this. This isn't safe anymore, my man. I'm sure if it was plugged in and never moving, which I think is the situation here, but I've got it all apart. It's 3 wires, a connection here and a connection inside the box. I can handle that. We'll do that. So now let's come over here and let's talk about the PA, our final section. Let's go down here and let's go spend a couple minutes looking at this. So there's little plastic washers that are down here that I had to take out and replace and put back in. This is our high volt lead that comes in from over here. And then we went in and we cleaned out the blower and made it so that the squirrels weren't in here anymore. It's still a little dirty, but it's a whole lot more blade capture than what we had going on before. This is just some of the dust I took out of the inside of that blower. Just some of the dust. It's like dryer lint and just life. I'm touching 30-year-old human skin, basically. That's all that's in there. It's part of life. You'll notice that the plate choke looks really glossy and pretty again. Well, there's logic that went on behind that. So I go to remove the resistor, and this wire is what was attached to the plate choke. Once again, let's zoom in here. So we're going to go to manual focus. Here we go. This is the end that went to the plate choke, so it's at something like this. This wire was broken and burnt. It's actually burnt. So it shorted over so hard that it burnt the wire off of the end of the plate choke. So what I did is this wire, the way that this thing was done is the wire would go around, goes in the cardboard tube, goes back out, and then comes back out again. Had a little hook on it. And that's what I went ahead and replaced it with. So we put brand new silicone boot wire on here, actual legit high voltage wire, not like mag wire or anything. We replaced it with high voltage wire. Put heat shrink compound, or a marine grade heat shrink on the connection down there at the glitch. Okay. And all of the epoxy that was holding this plate choke was just flaking and falling off from age. So I went ahead and re-glued this, and this is just Synelic that we put on here, and it worked perfect. So we restored that. So in the process of cleaning the thing, I went and opened up the input deck. Look at that. I still got to blow this out again. That's just what has fallen out of the blower. Look at this. That was all filth that was in the blower. Hold on a second. Let me hit this with a vacuum real quick. Sure. Go to college, they said. Get a couple degrees and some bullshit, they said. Spend all that time and some money, they said. Then spend the rest of your life not working on anything you got a degree in, but spending the rest of your life working on stuff you figured out when you were like 15 years old. Proof is, you get to spend most of your day breathing old man dust. Okay, so this thing has been burned up before, and it has been repaired before. The reason I know this is because that board looks like it has had a blowtorch taken to it. Now, if I remember correctly, the thing went down once before, but he took it into Ten-Tec and they repaired it. the same resistor looks like it has gotten way hot, but it still tests within value. The disk capacitor behind it is still technically within value. The only thing I question is this read relay. It's this white bit here. So when I pulled the airbox cover off, I was a little shocked when I got down in here. I was like, oh, this doesn't look so hot. I think we're all right. I don't think that that is a point of failure. There's just a lot of soot left on everything from when this resistor at some point in the past decided to let, when this resistor right here decided to let the smoke out at some point in the past. And if I'm not mistaken, that's part of the biasing circuit. So if I got to replace that read relay, it means I got to make a call to Elliot tomorrow. But we'll get it. This took a lot longer than I thought it would. I thought I'd just have to replace these two resistors. I didn't think I'd be out here fiddly farting around for as long as I have. So tomorrow, when I come out here, because I'm ready to be done. Today's been an incredibly long day for me. Tomorrow, when the sun is up and I can run the air compressor and stuff, we'll get it all clean and speckled up, nice and neat. And then we will first bring it up with no tubes in it, because I have zero faith in power supply, I have zero faith in circuit, and I have zero faith in power wire. So we'll replace our power wire that's feeding the whole device. Then we'll bring this up slow. And what I mean we'll do is we'll take and put one of the legs on a 110 volt variac and bring it online really slow. I'll probably create another piece of phenolic like what I got going on here. This is a shorting crowbar for isolation. We've got that up against this piece of phenolic, and we've got a bypass trigger like this also over here on the power supply that we have bypassed. So I'll create another one that screws into this hole and holds this switch up, so we can run it with the lid off, break all the rules, break all the rules and be dangerous about it. But we're going to observe personal safety. You know, have all our personal protective gear on, you know. The glasses over the eyes, hearing protection, and an aluminum foil cup on our crotch. We'll power this thing up and we'll watch it run. Remember, the amp doesn't really care if the tubes are in it or not. The only time they care if the tubes are in there or not is if the tubes have got a problem. And then it's going to speak loudly and very vulgarly to you when it does that. And it's going to call you all kinds of crazy names. Come here anytime, my wife. You know that. It's your freaking place, too. Oh, my wife just come out, just talking to me. Screwed up that whole last take. Gentlemen, here we're at. This is where we sit. So, we covered the plate choke falling apart. I made this sound like this was going to be simple. Oh, I just got to hook it up and run it. No, this transformer has been out 4 times. So far, we've discovered quite a few little defects over here in the power supply. We replaced that resistor. Replace this resistor. The relay that attaches to that resistor was effed off, as in like it was welded solid. And then the other thing was that we didn't have any power coming through the umbilical over to the PA. Okay, so the lights weren't turning on, nothing was turning on, and what that ended up being was there's a switch that controls the high-low tap, controls ground anyhow. It also feeds through the fan switch. It's the red wire that's down in here. I've got power on this, so I got to be very careful where I put my hands at the moment. There's like 220 volts or 3,000 volts in this thing, so I got to be careful where I put my hands. Anyhow, we had a wire that was broke off, and the way it was wrapped around, you couldn't see it was broke off. So I pulled the relay out, replaced the relay, put it back in, put that back in. And then I looked over and I seen this little tiny, like, it looked like the top end of a wire was just kind of hanging, but it wasn't soldered to anything. And I'm like, look, it solders right here. So I pulled the wires all back apart, stripped it down, retwisted it, put it back together. And the end result is, now, when I first powered this up, I had high voltage, but I had no display. Both of the meter bulbs were toast. So we put 2 new meter bulbs in it, and I'm going to probe over here. There's a the high voltage connection that's here in the back. We're going to probe on it. And right now we got 1,530 volts. Let's see here. We're on low. So let's turn this off. Let's change that to high. We will turn this back on again, and we will re-probe. And we now got 2,639 volts with no ripple. So that means we've got the power supply restored to full functionality. We've got head unit power back. This checks out, that checks out. So for the sense of safety, after I verify that this thing is fully discharged down to 0, we'll short out the power supply. We're going to put the lid on the power supply. The transformer is only being held in by 1 bolt at the moment, and that's so the core has common ground. Okay. Once we get this bled down, I'm going to put the case on it for safety, and we can set this aside because everything in here is good. Okay. And then we're going to go focus on this. So that means I'll hook up the high voltage to this, to that, and then we'll test the high voltage circuit. Then we'll bleed it down once again, and then we're going to put our tubes in here. But before we go that far, I got to flip this over and I got to seal up the bottom side of the RF deck. So, moving right along. We're moving on up to the east side. Power supply is working, and we got deluxe lighting in the apartment in the sky. We've got operate, indicate, we got our lights all working. This portion is fixed. This was a mess. This has been repaired. This is all fixed. Oh, I had cold solder joints on the primary socket that comes off the power supply and everything. All that's been fixed, tested, good to go. Now we can turn our attention to this, and I can move this, set this down on the floor, and quit having all my workbench space stuck up with it. Because I'm not going to lie, we're going to hook this up. We're going to get the tubes in it, and then we're going to run it for quite a long time, like probably the rest of the day and into tomorrow, before we even try to put high voltage on those tubes. So let's get that together, and then we can work on this. Okay, so I got the power supply sitting over here in the corner of the bench all buttoned up. I don't have all the screws in it yet because I want to replace the power cord. So I'll do that last. I want to overcome many issues that are over here in the deck yet. So we've got a ground going between the power supply and the cabinet, even though that there's one inside the umbilical. 1 is none, 2 is 1, 3 is even better. So we're going to err on the side of caution. We got the high voltage hooked up. So now we have high voltage circuitry that runs over to here. And the switch is plastic, so we're relatively confident that I'm not going to get electrocuted as soon as I turn this on. I've got this on EP, which should show us our high voltage here. I currently have the fan on slow and the voltage on low. So we're good. Absolutely good. So let's test it on high, make sure we have no breakdowns in high voltage. Which we don't. We're good. We're right where we want to be. So let's go ahead and we're going to shut this down and let this meter bleed to 0. And then we'll ground everything. And then we'll disconnect our cables. Because we're going to pull this high voltage lead out. There's like a foot there between my hand and the box, by the way. Like I was saying before, I got really interrupted by the phone. Again, today, on this project, for the 100th time. We're going to pull our cord out of here, because what we're going to do next is a long process. So we're bled down to almost 0. As you can see, we're sitting about a needle's width above absolute 0. So let's get out our chicken stick and let's neutralize this thing, and we'll get the power wire pulled out. Okay, let's see if we can get this done and the phone not ring. See what we got here. Ooh, paper towel. Nice static bag. Sweet. Held together with packing tape. All right. This is a C2000 4032, reprinted 3CX800A7. This part number is the Chinese part number that we should all be paying attention to. C2004032. Reason that's important is because the Chinese refuse to let us know what their crosses are to our American tubes, but they make replacements. It drives me crazy. So that's the direct drop-in replacement for a 3CX800. That is an answer to a lot of ham radio operators' dreams. Right there, I'm here to tell you. Let me slide the other tube in. Okay, let's do the second one. Maybe I can get through this without the phone ringing. These were sold to this gentleman by another nice guy down in Arizona. Apparently he'd figured out the cross. So C200 619 or 6104. And the reason I got rubber gloves on is because I want these tubes to show up as pristine as they came out of the box from me to this guy, my customer. And so I don't want my grubby little oily hands to leave fingerprints all over everything here. Now that's not attached to anything, but I'm still over here trembling like a little schoolgirl.
Oh, is he gonna give me a kiss on my first date?
I'm trembling because I just made it this far in life by a miracle, I think, and I don't want to get electrocuted, so, you know, can't be scared. Just gotta really be humble and respect it. Even though it's not hooked up, I'm all, it's like a boy. Oh, she's gonna let me touch her nipples. Okay, so let's get some chimneys on this shit. Let's, there's our silicone chimney. We'll get air moving along here in just a second. We're gonna put our paper insulators in here. Actually, let's go the other way around with this. There we go. The paper slash insulator slash reinforcement, all this really does is allows us to have some integral strength to the boot, this high temp, high voltage boot. And this will allow us to get air forced up through the tube. Now I don't have to worry about nothing leaking. Slide that down on. Okay, so I got a good seal against the base of the air box. Let's bring the FLIR on. Now the whole idea behind this is that we don't want it. First off, it's a Chinese tube. Okay. Can't speak to the Chinese tube seals. I'm pretty sure they're based off of the same technology that we have here, where you assemble the tube in a jig, you throw everything into a hydrogen furnace, you melt all the little bits together with different kinds of abrase. There's a special kind of adhesive that holds the, I don't even want to call it adhesive because the temperature's so high. It'd be a special form of abrasement that allows us to bond glass to the copper nickel that the tube's made out of. There's a huge book on this. I'm getting ready to do a whole thing on tube construction, how you can go about taking the tube apart, what you got to do to repair it and put the tube back together. Some I've been working on the side now for a couple of years. It's become very pressing in the last year, which I'll cover in another video, but believe me when I tell you, I'm working on it. I got ideas. That's all I'm going to get into. But air is a very prevalent molecule, okay? And then there's a whole bunch of other gases that can form inside of the tube just from them sitting, okay? So you don't ever want to Put the tube in, slam the voltage on it, the high voltage, this side. You want to create the perfect environment, because the hardest part that you're going to have out of making this tube work is going to be that very first time you hit high voltage to it. So we're going to create an envelope so that we can get air coming through the tube, and we're going to let the filament sit there and cook for a little while. If the seal has gone bad on the tube, the filament's going to cook off and the tube's not going to, it's going to get real hot, and then it's going to cool way off. There's nothing we can do about that. Nothing. I can't stop it if the seals are bad. Main problem that most guys have is they'll take the tube, they'll slam it in the amp, they act like it's a transistor when it is not, and they won't let it have any warm-up time, they won't let the filament stabilize in the environment at all, and they automatically slam it right into operation. For me personally, we're going to turn this on now, and we're going to watch our tubes. So we're going to take this picture, and you're going to see, inserted in this picture right now, is the top of the anodes of the tubes have already started to warm. And that's from the little filaments inside heating up, making joy juice. Take you another picture. Now you can see the cores of the tubes are starting to heat, but they're not getting incredibly hot. So we're just going to sit here and we're going to watch this just for a minute. That tube is at 75. Our ambient air is at 77 or 73. Core is 74. Core is 77. Here, let's change how I'm viewing this also. It'll make it easier for everybody to understand what we're doing. There we go. That's the ambient air pressure, or ambient air temperature. And that's the top of the tube. The other thing you got to think about is that reflective surfaces have a tendency to emit energy, heat energy, in a different pattern than what this gun is perceptible to see. Okay? So in an ideal world, I would take, there's certain different kinds of heat coating that I could put on the top of this thing that would emit the infrared energy that this thing is trying to measure, and give us a little bit more accurate reading. Now it's up to 77 degrees, which is good. This is what we want. We're going to turn the lights off so we can get rid of the infrared picture that's above us that would normally be the lights. Our blower motor is at 78 degrees, but the tubes are coming up quite nicely. Okay. I'd like to see them in the 80s, preferably, and I'd like to see a little bit hotter heat signature in the inside of the tubes. Because to me, I feel like I'm getting a reflective reading off the top of this thing. $73, $73. Cabinet is 72. Let's go about this another way. Let's go ahead and lift the skirt off. Oh yeah. This picture is worth 1,000 words, the ones I just took. Let's turn this on for just a second. We're in good shape. We're in literally great shape. Let me put this back on. Okay, now hopefully I filmed this in such a way. Come on, slide back over the tube. There we go. Hopefully I filmed this in such a way that when I put in post these pictures from the FLIR in line, you'll be able to see what I'm talking about. Let's get air moving back over that tube. I don't want to do anything that might not cause this thing to be perfect. Okay. The gun's so sensitive, you can see where I was holding my fingers on it. What I wanted to do was make sure that the filament, the base of the tube, that this was heating up. And that's what we were looking at from the side view, was the temperature in this porcelain. Well, guess what, gentlemen? I'm out. We're going to call this good for today. And now I'm going to sit here and I'm going to let this run overnight. It's 2 o'clock in the afternoon, and I will probably just let this sit here and idle all night. All night. Like, I probably won't touch this again until 7 o'clock tomorrow. Is that really necessary? No, it's probably a little overkill, to be honest with you. But there's a lot of money wrapped up in these little guys. A lot. So, the other thing I got to wait for is for our OPT and our standby to come off of here. We're still in standby mode. We'll see if it trips without having the high voltage attached. Should just be a base on timer. And if it doesn't trip out, I'll figure that out tomorrow. But for right now, I know that the filaments are lit, and I'm making sure the tubes are thoroughly degassed. Because, well, let's face it, they're Chinesium. This could be 3 to 5 minutes for us to have this light shut off. I love that this was in 10 meters. I haven't played with it. Here, we'll pretend we're in 75. I'll make everybody in the amateur community feel better about things. It's like watching a pot boil, water in a pot boil. We sit there and watch. Does it take longer or does it not? I'll see you guys tomorrow. It is 10:42 at night. I'm getting ready to go to bed. I thought I'd come out and check on everything. Right at about 80 degrees. I was really in a rush in the previous segment because I was trying to get stuff done in between the phone, which is nonstop rang for almost 2 weeks at this point, because of the other business. I told my boss, I said, man, I don't know how much longer I can continue doing this for you. I said, I haven't been able to return any of my phone calls on my own business at all. It's like 8 o'clock at night when I was finally able to be done with the other business. The cooking the tubes in is actually really, really important. Especially they've been sitting for a long time. The getters don't really burn off the oxygen. They more or less absorb it. And they'll uptake it. They'll pull it into itself. And then over time, the little molecules can wick back out of the getters. This portion of the thing here. This sacrificial metal that's down here. These also serve another purpose in the tube. But the gas that's inside the tube that's created just in the function of its operation, some of that can lead to decreased dielectric insulation properties. Fancy words, very complex way of saying it can decrease its ability to insulate itself. So some of the gases inside of here can, if we lose that vacuum that's inside the tube, which is really important to increasing our insulation value. There can be gases present inside the tube post-production after you pull the vacuum on it still, because underneath this cap, this cap on the top of the tube, the anode tit is a valve. They're not a valve, but, well, there is a valve on it at one point. There's a stem that's on there that they hermetically cap off. I'm currently looking for the tool that allows me to hermetically crimp Copper and copper nickel, by the way. Once again, back to that tube project I'm talking about. And your regular HVAC crimp tool does not do the job. No. Anywho, you got to burn the tubes in to make sure you have the best chance for success. All right? There's two competing theories here. One, you just plug the tube in and rock and roll and go for Jesus. And the other part is I'm going to try and create the best environment inside that tube that I can to maintain the chances of success. Okay, so you have one opportunity to get this right. One. If you have gas or any trace molecules that are inside the tube whatsoever, and you have a high voltage arc that takes place inside the tube, tube's basically done. The only way you're ever going to get it to run is at a lower voltage. Or cook it for a long, long period of time, and hopefully that the carbon score that's now created on the inside of the tube from the arc over dissipates or gets reabsorbed back into the getters or the filament. If we don't do this process, we're not creating ourselves the best chance for success. So I'd rather go this route and let it sit for 5, 6 hours, 8 hours, 10 hours. Like in this situation, we're going to let it cook for like 10 or 14 hours. I don't want there to be any chance that this guy who has spent very hard-earned money on getting these tubes to get his baby back working, to be able to go, no, you didn't give it an honest effort. Just being straight up with you. Straight up. I'd rather cook this for, I'm really busy with the other business, so I can turn this on and walk away and forget about it for a day and know that when I go to put high voltage on this tomorrow, I'm not going to have a problem, versus getting in a hurry, taking a risk, and then saying, oh, no, man, sorry, your Chinesium unknownium tubes are effed off. That makes sense? Don't risk it. It's just like the air bottle test on a 3500Z. It's not worth risking it. It's not. Take your time. Go slow. Save yourself thousands of dollars. Period. Of course, then there's other guys that say, nah, it's not worth it. Hook it up, run, some bitch, put power to it. I've never seen it make any difference. I asked that engineer at iMac one time, or Conco one time, what his thoughts were, and he looked at me like, oh, was the tube new from us? And I'm like, no, I'm speaking in general terms. Oh, then I can't speak to that. I can only speak to the scientifically perfect blah, 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 that we provide. Got it. This isn't an American-made tube. These are Russian tubes, right? Not saying that the seal technology that goes on here is any better than the Chinesium seal technology that's on these tubes. But what I am saying is that there's a little bit difference in quality control from American-made components versus Chinese components. And we all know this since birth. When we were children and we were playing and we would go to the drugstore and buy shit at the drugstore. If you flipped it over and on the back of it, it said made in China, you and I all of us were genetically, mentally trained from birth that if it said made in China on the back of it, that means it was crap. Because it was. Well, ever since NAFTA and Bill Clinton and them signing away and lifting all the tariffs on all the major corporations, 90% of the stuff that we consume in this country, it seems like, all come from China. So now we have to live in that environment where we have to accept the fact that we are consuming and using parts that are of a substandard, sub-ish standards. And how do we go about bringing them or maintaining or achieving the next, back up to that same standard? And if all I got to do is let this run for a little while, I'll let it run for a little while. Not that that's going to help the manufacturing standard, but I know for a fact that the vacuum that's inside of this vessel is going to be at its maximum. That and getting the heating cycle on it, now we're stressing the seals, or we're making sure that we can maintain that vacuum. That makes sense? Just pushing on it a little bit, but in the same breath, just letting it ferment. Like good corn whiskey. I'm just saying. Yeah, here we are. By the way, got new power wire for him today. Got a 10-foot lead on it now, which beats the 5.5-foot lead that was on it before, which is literally disintegrating every single time I touch it, so I gotta quit touching it. All right, I'll see you guys in the morning. For any of you that ever have a question about some of this knowledge, there's a whole giant list of different books out there. You just have to be willing to go search for them. Materials and Technologies for Electron Tubes. Walter H. Cole, okay? He wrote this book for the Collins Radio Company. It was printed in 1951, but there's 505 pages of valuable, sexy, wonderful, juicy, titillating, make your hard like you're 16 years old again, knowledge. And these are all the different sources, and then this is a peer-reviewed book where multiple people in the field have looked at it and said, yes, we can agree with this. And yes, this is, I mean, it's got 4 pages of people that are reviewed and fact-checked everything he says in here. These are all the different publishers of the same book. He spends an entire 100 pages talking about just glass characteristics, how they go about outgassing, how they operate inside of high voltages and electron bombardment, how glass envelopes interact with different kinds of metals that are heated, not heated, and within an RF environment. He spends an entire 100 and something pages talking about just welding on tubes and the different ways of going about bonding them together and assembling them. He spends probably 30 pages talking about the seals that take place between the ceramic and the nickel copper metal that they use, and all the different breakdowns of tungsten. I mean, I've read this entire book 3 times. Don't be afraid to enrich your mind with knowledge. If you have a question in this day and age that you don't know, in this day and age that we live in, believe it or not, the internet can be used for something more than looking at boobies. It can be, believe it or not. This is one of about 4 or 5 books I've read on this subject just in the last 4 months. I read a 1,200 page paper that was all written about different welding, puddle welding, friction welding, and abrasing techniques of nickel copper. Because once again, I've got another project that is way bigger than these little pair of 800s that's getting ready to come out, that I'm working on in the background at the moment. It might be out before the end of the year. We'll see. Depends. It really depends on quite a few things. But we're working on it. Where I'm restoring a tube that is very valuable to me, but nobody else in the tube business seems to think it's all that important. Either that or they don't want to deal with me because they're scared. I don't know. We're going to find out. But everything I'm referencing is believe me when I tell you that a large portion of what I say here on video sometimes is kind of a shtick. It's a little bit of a put on, because I don't like to use big words to impress people. It doesn't get anybody anywhere, ever. And if you're one of those guys that feel like you got to use 3rd level English, 4th level English, and what I mean by that is college plus English to describe what you're talking about instead of just using plain basic English. You'll see my eyes glass over and I'm like, dude, I gotta go. So understand that I try to have a little bit of knowledge behind what I'm talking about. Sometimes it's right, a lot of the times it's wrong, but I think I do all right. 9 times out of 10 we get to hit a home run. So yeah, I just wanted to throw that out there. That's a really good book. If you don't know anything about tubes, go read that book. You're going to know more than 99% of most of the people that you run into in the radio world. Honest. And then once you read that, if you can keep your eyes open through that, because it's a tough read. It's a pretty dry read. I mean, it's It's like reading an operation manuals for like a Commodore 64. It's a tough read. If you can get through that, there's about 4 or 5 other books I could turn you on to that I've read that will really open your eyes, and you start to think about things like just the whole segment in that one book about outgassing with like radio bombardment of lead solder tin mix. Oh, it'll open your eyes up on how you go about bonding something inside of a vacuum and then exposing it to a high RF environment. It'll make you think. You're like, oh, okay. So the tungsten that's in here, depending on what the tungsten's coated with, surface coating or integrated crystalline grain structure, the tungsten wire, how it's gone about, how it's been made, will all react differently with how the solder is going to outgas, or how the abrasement material is going to outgas. And what do you want to make your abrasing material out of? It has to be very specific for a lot of different reasons. So it just all depends on how deep down the rabbit hole you want to go. At the end of the day, we want to make it work, right? Yeah, that's what I get paid no money for, right? That's right. Okay, so now we've cooked in for literally almost 24 hours. I got busy with the other business. Off. Now we'll let this rest for about 15-20 minutes, and then we'll pull our chimneys off and we'll get our anode caps put on. Got to reattach this one, it came off in shipping. Get it snuggled through the little booties, and let's get this thing set up to put some voltage on it and see what we got. The scariest bit to this whole thing to me is stepping on that foot pedal for the first time to put it in transmit mode and take the tubes out of cutoff and put them into actual operation, like apply bias. So I'll put that in standby, put that in PTT. I mean, we're literally going to do a zero signal test, and what we're looking for is I want to see the voltage drop on the power supply over here, and then I want to see the plate amps come up a little bit, and then we're just going to sit here and stand with our foot on the pedal and watch the tubes heat up as they start to activate. But the hardest part's going to be getting the high voltage on the anodes and then hooking the high voltage up to the looked like I almost touched that, didn't it? I mean, I literally got 10 inches worth of room between me and that plug. The hardest part is going to be getting the high voltage on the tubes, and it's either going to pop as soon as we turn the high voltage on, which is going to indicate to us another problem, either it be a problem in the tubes or a power supply, which I'm pretty sure the power supply is correct. So either it'll pop as soon as we turn it on, or as soon as we step on the foot pedal, it's going to go bang. We'll find out. Let's get this done and over with, and we'll wait for that to bleed down to zero. Even though I don't have a power cord from here to here, there's no way for me to look on the inside of this power supply to see if I've got voltage if I'm just the normal layman. What I'm going to use is a high voltage probe. We'll stick it in a hole. We'll make sure we're at zero before we go and attach our high volts. The lead, that is. So, okay, we'll be back. Zero. No voltage. Zero. Okay. We don't need this for right now. So, pull that out of the way. Let's see, where did I stick the high voltage lead? If it was a snake, I'm sure it's going to bite me, because I've looked at it like 5 times in just the last 10 minutes, and I don't remember where I set it. Man, the older I get, the more scatterbrained I become here. I need this in a minute, so get this turned on. Jeez. It's right here. Okay. So, all right. Then we're going to run an auxiliary case ground. which we should always do. There we go. Okay, well, need safety squints. Where are my safety squints? Protect our eyeballs. Let's see, I got my hearing protection on. I got my aluminum foil cup on. Yay! Have high voltage. We're on low, of course. We've got high voltage. And the tubes didn't arc over. That's great. Ooh, okay, it's one major hurdle covered. Now, let this bleed down to 0, and I'll hook up the foot pedal and I'll get ready to do the 0 signal test. Okay, got the foot pedal hooked up. Zero faith in this thing. I don't trust it right now at the moment. So, we don't want to step on the pedal until the timer kicks out and this goes to green. Nothing. Nothing. Okay, cool. Put that into operate, PTT. Okay, let's see what happens. Okay, so we fired this up and we were getting, when the tubes started to warm up, they came pretty much like they were coming up into operation, and the tubes were at 160 something degrees by the time the operate light came on, and it was stuck in transmit. Although I could take the operate standby switch and flick it, I could hear the relay back here clicking. I got the high voltage disconnected, as you can see, 0 and 0. I'm waiting to do another test here. Even though I could click this and I could hear this relay clicking, there's another switch, or another relay that's a read relay, which is down in the bottom of this thing that controls the transmit, or pardon me, bias flop. And I think it might be stuck open. As in, like, it's making this thing think like it's always in transmit mode. So the test that I'm running, which is kind of a mood point, is I want to see what the timer does. Once this goes into operate, I want to flip the switch and see if I have the same exact processes of operation that I had before. But I have a feeling that we're going to be disconnecting this thing, flipping it over, and going and playing on the inside of the RF deck. Okay, so now we're into operate. So I can hear this relay back here fire. And when I flip it forward, I should be able to put this in QSK, flip this back and forth and operate. And when I put it into operate standby, it shouldn't do anything until I step on the pedal. Yeah, it's stuck hard in transmit mode on the bias side of things, and I've got no foot pedal input. Okay, tubes lit, tubes took power. Tubes are obviously coming up off of 0 signal. I was pulling, oh God, about 120 mils. It's up here to the second mark on the window, which is perfect, but we're not controlling what we're doing. So I gotta wait for the high voltage to bleed down on the power supply, so then I can go and I can move everything around. We'll flip the bottom of this thing over and we'll start figuring out the key-in circuit here. I just need you guys to see this real quick. We're set here on audible tone, and we got our 2 test leads. One is hooked up to this is a commonly open relay. And I just got myself a little 9-volt battery here because this is a 5-volt relay. Oh, it could be 5 to 12 volts. I can't tell because the outside of the relay, the numbers are too effed off. So I'm going to go with it's a 5-volt relay. Err on the side of caution. So I got a little 9-volt hooked up to this, and I've got this set so it beeps if the relay makes connection. I'll show you what this is all about here in a second. Okay, so we know this little read relay is good because it looks like asshole on the outside. And this is after I cleaned it. You guys think back into a couple previous segments ago, I was talking about the board that's in the RF enclosure section, PA section on the amp. And yeah, hold on. So, you know, when you're spitballing a repair, if you got a board that's got visual damage on it, take it out. Let's take a look at it. So, this is the, this has got a, the input RF goes through this board. Your bias circuit goes through this board. Part of the keying processes of the amp, and a secondary function goes through this thing. I might actually have to sit down and look at a schematic on this one, because if this, what I just didn't fix this, I got problems on another board, and I think it's on the front end of the amp, but it also could be on the back board. But I showed this to you in the previous segment where I was talking about this inductor that was in here, and how I felt that inductor still might be in tolerance. It is not. That inductor, I pulled this board back out and I looked at it. The inductor that is around it, or that one inductor, was completely open. Had no conductivity, no unihenries, no nothing to it. When I put it on the big meter, it was it like 190 meg or some shit. Basically, I'm reading the resistance of the outside of the component from post to post. I was able to get a measurement through it, but otherwise it was, for all intents and purposes, it was an open. So let's see, this here, if memory serves my stupid little brain, is an 8.2, and the one that was in here was like an 8.5. So it's not going to make that much difference in the isolation. It's just really not. I pulled every transistor on this board off and tested it. I've checked every diode and every resistor in circuit. The only thing I haven't done is do the capacitors, which, unless they read as a short, or they've got some obvious physical damage to them at this low voltage in this particular environment, I don't think I'm going to have an issue. But the main thing I needed to do was address this inductor being completely open. This diode D10 was also open. Replace D10, replace the inductor, check that, check this, check this, check this, check this, check this, and check this. This inductor is good. I went through and checked all the other diodes in the circuit. They come back golden. Checked all the other resistors. Everything looks really good on this board. So I'm hoping that once I reinstall this, we'll have functionality and I can sit here and go, look, I fixed it. We can only pray, right? We can only pray. Hey, fuckers, no making fun of my pink toothbrush, by the way. My daughter gave me that, goddammit. Let's see if we got it. If it's still engaged, that means I pull the tubes out. I got to run this thing without the high voltage attached. Yada, yada, yada. So we'll see what happens here. Well, that answers that question right there. Straight into transmit. So either I got something back feeding, or I've got something back feeding, or I got something shorted. Okay, time to get medieval on it. This is an interesting set of problems that are developing here. So I went and I systematically removed all the plugs one at a time and went through the startup process with the box off the transmit side. So we could isolate that out. And we're seeing an excessive amount of current. I'll show you where the problem lies in. It was happening no matter what. No matter what I did with the keying circuit, it was happening. So now we got operational mode, right? I have now got transmit function. Okay, I got transmit function back. It's not showing a bunch of excessive current being pulled on the front, but when I go and I look at the tubes, them little guys are working their guts out. So I know it's not part of the keying circuit. Let's go ahead and let's shut this down. Let me grab the blower and let's pull the heat out of these tubes and shut it down because it's still acting like it's in transmit. Let me put some air on these. Give me a second. Okay, we're back down in the 80s now. I'm thinking that we're just fooling the because here's what I isolated it down to. This is our connection for our actual bias control here. This blue lead, and it plugs right into this board. Everything that's attached to that board is good. If I isolate out this board, I get transmit function back, but I'm still seeing current draw. Well, you know what? I should probably put the ampering on it and see what kind of current I'm actually pulling. So 3CX, this is grounded grid. I could literally just remove the tube from the equation and run it again and see if I still have relay function with the board in line. And that allowed me to have meter function, which is partially reliant on this board, I do believe. It's something timed, because you can hear the power supply. It'll sit there and it'll run, and then all of a sudden it goes, dong, just like instantly, somebody flipping on a switch. And then it'll run, and then I get transmit mode. I mean, it'll come out as standby, which is just the timer counting down. And it's very consistent. You turn it on about 20-30 seconds into it being on, then it'll go click. Something inside here goes click. So I've got to measure what's changing in the deck. First, I'm going to isolate the tubes, see if it does it, bring the board back into play, and let me think about this some more. Oh, this Ten-Tec. How I love thee, let me say the ways. Well, since you guys have seen this last, it's now a whole nother week has gone by. I just got completely covered up with the tow business. Now I'm done with that for this week and next week, and then I got to run it again for another 2 weeks. I'm done for the rest of the year. So went ahead and we put the new power cord on it. It's got a brand new power cord on it. The other one was just disintegrating and falling apart on us. I couldn't handle running that anymore. I didn't feel safe with it on there. I've had now three separate instances where I go to put the transformer in and something not be connected all the way because the pins on these plugs have been, this thing's been in and out so many times. So it's starting to show those kind of issues. I ended up having to reflow a whole bunch of joints down here on this board. We still have the issue with the amp going into full operation mode without the foot pedal being dropped into place. But we have to stop working on this. I gotta pull back, I gotta order some parts. One of the things I have to order is down in here is a relay. It's at junction or part number K7. There's a Potter Bumsfield surge protection, aka soft start, that's on this thing that the relay has welded itself in the not passing position. So when you go to turn it on, the 25 watt 10 ohm resistor that's down in here is getting hotter than hell, and we can see it represent itself over here. Check this out, watch the high voltage here. Oh, don't have the high voltage connected. I gotta give it a minute for the high voltage to bleed off. Here, I'll show you what I mean, just give me a second. You should see the text conversation I'm having right now with this guy. I am, I just have to do a YouTube video on this. People are getting themselves all messed up in their head. It's, oh my God. Anyhow, back to the topic that we have here at hand. Watch the voltmeter. And then this will slowly start to drop. Or maybe it won't today. Maybe that relay decided to latch today. I think that relay decided to latch today. See, this is the reason I've got to go get a new relay, is because I can't send this guy this amp back and be like, oh yeah, it's good to go, and then him end up having problems. Turn on my FLIR and make sure that our soft start resistor is working, or is not getting hot, which it is not today. Wow, okay. I don't understand. Let's let it run through its sequence of events. I want to replace that relay no matter what. Our bleeders are working. Our bias is working. The tubes are ice cold. Let's give it a second here. I want to replace that relay that's over here. And I've got to order some 24 volt light bulbs for the front of this thing. But the main thing that's got me concerned is this. And if I overcame that by redoing all these pins last night, I'm going to be amazed. No, it's starting to pull grid. I've been over this bias circuit 3 times and I don't understand why it's staying latched. But that soft start circuit's going to be an issue. So, needless to say, this is where I got to step out of this. The tubes are okay. We verified that. Yeah, I want to replace that Potter Bumfield relay that's in there. I know it's not working right. And if it's a 50-50 chance, it's not worth taking the risk. I want to get this thing just right for this guy before I send it back. I've had this in and out a bunch, this power supply. And just want to make it right. So I'm going to pull back off of this. I'm going to get a new relay coming. I'm going to get some light bulbs coming. I got a couple other little small parts that I want to pick up. But this is where this is going to sit for about a week. So I'm going to fold this thing up for a minute. I'm going to set it aside. I'm going to shoot a bunch of other YouTube videos the next couple days. So you guys are going to see a bunch of new YouTube porn coming out. And I'm going to come back to this next week. And I'm going to do a part 2 of this. And it should be pretty quick. It should be really, really quick. I'd hope. But that's where we're going to sit for now. We got the tubes in, got the tubes running, got the key-in circuit fixed finally. Got the glitch circuit fixed finally. Got the soft start circuit aligned, but The relay is intermittent. We got the fan high and low switch. There was a wire that popped off of that. We got that figured out. But for the most part, we're like 99% there. We're just missing this one little relay, which I don't have, and I'm not going to go jerry-rig another relay in there. So, hey, making steps forward. Believe me, we're coming back to this. Gentlemen, my name is BBI, and I want to say thanks for tuning in. Believe me when I tell you, I got a bunch of really cool stuff coming. A bunch of really neat projects coming down the pipe. And no, contrary to everybody that's been texting me the last 2 weeks, I'm fine. I've just been off working at the other business. So, it is what it is. Okay, I'm going to run. The next thing you're going to see is a video on a 4CX800, I do believe. Gentlemen, I'll see you. Bye-bye.